Okay, so day 7, L2, more math for chemistry. This is day 7, lesson 2, more math for chemistry. This is the solutions video. I'm not going to show all the solutions. I'll show a good number of them though, and we'll go ahead and talk about some of the things that we're going to discuss in class here. So this was formally assigned on Wednesday, September the 9th. That was last Wednesday, and it was formally due last Friday. Don't worry about that. I'm going to basically go over what the deadlines are really for this first 2 weeks worth of assignments, which are your foundations assignments, and we'll talk about that in class on Monday. All right, so let's get started on the first question. This is an AP style question, although it's not an AP level question. But AP questions ask you to think and to reason things out. They're not just about plugging in numbers to formulas, as I've told you before. So let's go ahead and read this and let's see what it's asking for. So a student places marshmallows on a piece of paper and measures their mass on a triple beam balance. The student records the following masses. So there you have that. The company that produces the marshmallows reports the average mass is. So there you have a true value that you can compare. The student can compare the measurements to that true value. So then there's 5 parts, and that's typical of an AP question, anywhere from 3 to 7 parts in an AP question. So describe these measurements in terms of accuracy and precision, and describe at least one factor that could cause the discrepancy. Giving reasons for experimental error is a common part of an AP level question. Not every question, but they'll definitely ask it in a few questions. So go back in the video to the dartboard example and understand what accuracy means, what precision means, and then apply it to this situation. That's what AP wants you to do. Apply something you know, a principle you know, to a new situation. Okay, compute the percent error. Okay, so that's in the video, how to do that. By the way, one thing you need to do, which I didn't tell you to do, but you need to do it to do the rest of the problem, is to compute the mean. So you need to take the average or mean of those 5 values. C, compute, no R, compute using a table and calculator, not a spreadsheet, the standard deviation of the student's measurements. You're never going to do this on the AP. I want you to do it one time to practice it so you understand how a standard deviation is computed. You can do it in Excel or Sheets, Google Sheets, but I want you to just do it by hand. It's just a simple table with 4 columns and 5 rows, and just go ahead and do that. Compute the standard deviation. And then what percent of the student's measurements fall within 1 standard deviation? That should be plus or minus 1 standard deviation. So you take whatever your mean is, you add 1 standard deviation to that number, you subtract 1 standard deviation from that number, that gives you a range. And you want to find out what percentage of these 5 values fall within plus or minus. For a normal distribution, it's 68%. But you don't really have enough values for it to be 68%. I mean, it's either going to be 20, 40, 60, 80, or 100 when you have only 5 values. So just see what it turns out to be. We learned that 68% of the values in a normal distribution fall within plus or minus 1 standard deviation. Well, I kind of just gave you the answer for this, but you can give another answer if you want. What explains the difference between your percentage and the 68% figure? Okay, so go ahead and do that. We're going to talk about that one in class. But I would go ahead and try to do the numeric part first, then we'll do the discussion questions later. Okay, now I'm going to give you some problems on logarithms. And what I wanted you to do is go to the slide or the part of the video that shows you the principles of logarithms. So I'm going to go ahead and pull that up. Okay, and there you see it straight from the video, and those are the properties of logs. So I just want you to practice a little bit with logs. They're not heavily used, but when they are used, you need to be comfortable. You don't want to be not having to ask a lot of questions about how does a log work. You want to be focused on the chemistry. All right, so let's go ahead, and there's the properties, and I'll toggle back and forth between that. The first one has to do very simply with this first principle, that a, some base number to the x power times that same base to the y power equals a to the x plus y. So let's go ahead back, and I'm going to go ahead and do that one on the sheet here. So there we have that same principle. So all I'm asking you to do is pick a number. So I'm going to say 2. And let's say x is 2 and a, so let me write that down actually over here. So a equals 2, x equals 2. It could be a different number. Really it should be when you're kind of doing this, but that's all right. And y equals 3. So it's saying a to the 2 times 2 to the 3, that's y, equals 2 squared is 4, and 2 to the 3rd is 8, so 4 times 8 is 32. So the question is, does that equal 2 to the 2 plus 3, which is 2 to the 5th, and 2 to the 5th equals 32. So I teach my math students this. I call it a small numbers test. If you're not sure if a principle, if an algebraic principle that's expressed in variables is valid, just plug some small numbers in and see if it works. And so that's what we did here. Okay, so let's do the same thing here. I'll try to pick a different number this time. Avoid picking 1s and 0s because 1s and 0s have unusual characteristics. For example, you multiply anything by 0, you get 0, so that's not going to work. Or you raise 0 to a power. It doesn't matter what power you raise it to, it's always going to be 0. So you want to avoid 1s and 0s, but pick other small numbers. Okay, so how about a to the xy? Does that equal a to the x times y? So I'll write my assignments here. A equals 2. X equals, I'll make it something different, 3. And y equals 4. So does 2 to the 3 times 4, well, let's see what that equals. Okay, so what you will do is get a calculator, and I am going to say 2 caret 3, that's how you raise something to an exponent, equals, that gives us 8, and then I'm going to do caret again, so it shows me answer, that was the 8, raised to the 4, and that equals 4,096. Okay, so that equals 4,096. Is that the same as 2 to the 3 times 4? That's going to equal 2 to the 12th. So we're going to go ahead and plug that in. 2 caret 12, 2 raised to the 12th equals 4,096, okay? So yes, what that does is that validates this principle right here, that is true. So we validated those two. That's what I'm looking for you to do. I'm doing it on the sheet. You can do it there or do it on line paper. Okay, 1 to the a to the minus x equals 1 over a to the x. That's just a general principle you should remember. So what it's saying is 2 to the minus 3 equals 1 over 2 to the 3rd. So let's see if that's true. Put a little question mark because we're asking the question, is that true? Okay, so here we go on the calculator. 2 caret, minus sign is this one down here, not that, it's the negative sign rather, not the minus sign. Minus 3 equals, and that gives you 0.125. Or I could do 1 divided by, we're doing the reciprocal of that, 2 caret positive 3. And that equals 0.125. So those both equal 0.125. So that's a valid principle. Okay, how about this one? And this is one that will come up in some of your problems where you have to take an exponent and pull it out in front of the log. That will come up in your problems. So let's go ahead and do that. So what we're asking is log. Let's go ahead and set our values. Let's just say log, let's say a equals 10. It's not a small number, but it's a common number to use. And let's say x equals 2. So log of 10 squared does that equal 2 log 10? Okay, so 10 squared we know is 100, so the log of 100. So here I'm hitting log and 100. Close the parentheses, and that gives you 2. Okay, or 2 log 10. So let's take log 10 first. Log 10, close the parenthesis, gives you 1, and 1 times 2 gives you 2. So they both equal 2. So that's a valid principle. Okay, these aren't hard, just testing out, see if these things work. Okay. The change of base, honestly, you're not going to use that in this class, but it's a really neat principle for logs in general. It says if you have a log of some oddball base, like 3, and then the number is 7, you can simply do this. You can say log of b to the 7, if that were 7. Let's go ahead and make it that. So let's say that x equals 3 and y equals 7. So what we're dealing with is log base 3, 7. Okay, so that's an oddball. So how do you deal with that? Because your calculator doesn't have a log base 3. Well, what you can do is just change the base, and you can pick any base you want for b. So you're going to pick 10 because that's what log in your calculator is set to do, is base 10. So you're going to simply say this is going to be equal to log. Remember, if it's base 10, we don't have to write the 10 there. Log of 7 over log of 3. Okay. And that is, you just do that on your calculator. Now, there's no way we can verify this because we really can't compute this directly on the calculator. But we can go ahead and just show that this is going to work. Well, I'll tell you how we can demonstrate it in a second. Okay, so I'll tell you how we can verify that. Okay, so log of 7, close the parenthesis, divided by log 3, close the parenthesis, equals, and it's 1.77. Okay, so how do we verify that? Well, what this is saying is the following. I'm going to write it up above since I have more space up there. It's saying that log 3, 7 equals 1.77. So what that's really saying is that 3, if I turn it into an exponential, raised to the 1.77 should equal 7. Let's see if it does. And there is rounding. I did round that number, so it's not going to be exact, but it should do it. So let's see if it does. So 3 caret 1.77, and that gives us 6.99. Close enough. Okay, so that does work. So the change of base is kind of a nice principle that allows you to do any base on your calculator by converting it to base 10. That's really what that comes down to. Okay, this one is really important. This is the inverse that we were talking about in the video, okay? You're going to need to use this in solving some of the problems. So just pick any number x. Let's just say x equals 4. So it's saying ln of 4, does that equal 4? So let's try it. So we have e is right here. It's right above the ln. It's a little blurry on the screen there. Let's see if I can focus it. Yeah, e to the x is right there. So how do you get to that? Is second. Let me clear that. Second, and then ln. So there you see an e caret and then something to put in there. And I'm going to put ln. So I push the ln button without the second. And it's 4. Close the parenthesis, and that gives us 4. Okay, so whatever you put in for that x is going to come out. Again, you're undoing the natural log. So that in fact works. That in fact is true. All right. Now this is the other direction for the inverse. If you take the natural log of an exponential of Euler's number raised to some power, it'll give you that number. So let's use 7 this time. ln e to the 7th equals 7. Is that true? So natural log, second natural log, that gives you, then 7, close the parenthesis. In fact, watch out, this could cause a problem. You have to close a second parenthesis. Okay, so be careful about that. Like that. And then you hit it, and it gives you 7. Okay, so that works. Okay, I'm going to leave this one for you to do on your own, so I'll check that one. And let's move on to some where you're going to have to use this inverse principle, so that's numbers 7 and 8. So if we go back to our slide here, there it is. So it's these down here, numbers 9 and 10. So you have an inverse for a regular log and an inverse for a natural log. Just really should call that a common log. Okay, so let's go back to that. All right, so you're trying to find out what x is here. So I'm going to circle this one. This is, put a little star. That's the one for you to do by yourself. You should be doing all of them by yourself. If you're just copying, you're not going to learn, and you got to learn to get by on that test. So here we go. What do we do for this? Well, we know that we can turn this into an inverse by writing natural log e to the 2x equals, now anything you do to one side, you do to the other, natural log of 3.2. So natural log of e is going to inverse. That means this is going to come out as just 2x. And the natural log of 3.2 you just do on the calculator. So natural log 3.2, close the parenthesis, and it gives you 1.16. I'm not worrying about significant figures here. I'm just kind of lopping things off where I feel like it, which is a couple places after the decimal. Is that bad? Well, we'll try to learn one thing at a time, okay? And if you divide that now, that will give you x equals 0.58. So that's your answer. Okay, let's do number 11. Okay, so what are we going to do in number 11? Well, we could use a natural log or a common log. We're going to go ahead and use a common log. So it's log. I'm going to take the log of both sides. Okay, now I'm going to use the principle where I can pull this out in front of the log. Okay, so let's just go ahead and compute log 20 and log 12. So x plus 4 times, and log 20, it's just very simple. I'm just going to do log 20. Close the parenthesis, 1.3 equals log 12, log 1,2, close parenthesis, and it's 1.08. Okay. So some of you may find the math a little tricky, so I'm going to go ahead and do it up here. So let me rewrite what I have. I don't think too many of you will find it tricky, but let's just be sure we're all on the same page, okay, before we go ahead. So I'm going to divide both sides by 1.3. Cancel. Gives you x plus 4 equals 1.08 divided by 1.3. I already have that on my calculator. And that's going to give me 0.83. And now I'm going to subtract 4 from both sides. These two cancel. And I end up with x equals 0.83 minus 4. And that gives me negative 3.17. Again, these numbers don't mean anything. They're just problems. There's no chemistry significance to this. We're just learning how to handle the math. Okay? All right. Okay, I'll do one more, and I'm going to leave the rest for you. Let me find what I want to do. Okay, these up here are all, you're using a log or a natural log to produce the inverse. Now down here, you're going to have to go in the other direction. Let me do one of these for you, at least one. Okay, let's do 14. So you got ln 5x minus 1 equals 7.3. How do you deal with that? Whenever you have the ln and you need to get the x out of inside of the ln like that, you raise both sides, you raise e to the power of each of these sides. So in other words, this. Oops, 7.3. Okay, so the right side here, this is something you can run on the calculator. This is an inverse. Anytime you got an e and an ln together, that should send off a little flare in your head that that's an inverse. All right, and so what's the inverse going to be? It's simply going to be this. Boom, it comes out. And then that's going to equal e to the 7.3, so we're going to come over here. Again, we need to use the second function, and ln, that gives us e raised to the x, and that our x in this case is 7.3, and that gives us a big old number. 1,480 is close enough. And now it's just an algebra problem. Okay, so we're going to add 1 to both sides. I'll come over here. Well, I better not run out of space. 5x equals 1481 because I added the 1 there. So x is going to equal that divided by 5. And I get about 296. Again, not a meaningful number in terms of chemistry. We're just learning logs, how to deal with logs. Okay, so these two, that one's going to be another e. That one's not going to be an e. It's going to be a, what are you going to raise that one to? You're going to raise that to 10. 10 raised to the log 4x. Okay, the inverse of a common log is exponential with 10 as the base. Okay? All right, so you do those two on your own. All right, should I do this one for you? I don't know. Let me tell you how to do it. It's not hard. This times this times this times this divided by this divided by this. Don't make the mistake of this times this on the bottom. No. It's everything on the top multiplied divided by everything on the bottom. One more time. This times this times this times this divided by this divided by this. You can do it all in just one long equation, but if you one long equation on your calculator. But if you do, I would double check it. Okay, it's very easy to make a mistake when you have more than a few numbers you're inputting. Okay, now what? It's this 5 plus negative 3, which is minus 3, plus negative 2, which is minus 2, plus negative 7, minus positive 6, minus negative 9. Minus negative 9. Okay. So I am going to do that one for you, and I'm going to just give you the answer so you can check your figure. So I explained it to you. Now I'll give you a check figure for that so you know whether you did it right. Okay, so if you did that, this is what you should have obtained. It was actually 33 and some more digits. I rounded it to 4. So it's 17.34 times 10 to the negative fourth. However, remember you have to adjust the decimal. Let's just talk about that last step and then you'll be done with this problem. But I want you to do this on your own. Be sure you can do these accurately. You will do chemistry problems that have this many scientific notation factors in them. And you got to be sure you can do these accurately and you understand the concept. Okay, so what do? We need to make this a number between 1 and 10. Where do we move the decimal to do that? So it's a number between 1 and 10. Well, you're going to move it over to here. So that's 1.734. That's a number between 1 and 10. And so again, don't try to memorize left plus right. You just reason it out. You made this number smaller. It went from 17.34 to 1.734. If you made this number smaller, you have to compensate by making this number bigger because you don't want to change the value of the number. So what is one position? Since you moved it one place over, you're going to move this 1. So which way do you go? Which is one position bigger? Because we need to make this bigger. And the answer is it's in the positive direction. So it's 10 to the negative 3. Okay, so that's your final answer. All right, now, one more. This is a silly problem, but there's a purpose for giving you the silly problem. First of all, it's kind of fun. I just picked some of your names randomly. And what it is this is called dimensional analysis. I didn't use that term in the video. It's not important, but it's an important concept. The name's not important, but it's an important concept. And that is that you line up your units so that they cancel properly to give you the units for your final answer. And once you have done that, then you know that your numbers are set up properly, and then you do what we did up here. You multiply everything on the top, and you divide by everything on the bottom. Believe me, you're going to do 500 of these types of problems. Not this type, not this problem, but real chemistry problems where you're going to have to line up units. Okay, so what I did is I gave you all kinds of conversions in there. And what I'm asking you is how many hectares can be made from 4.7 anaes. So what you do, and this may take more space to write. You may need to do this on 2 lines, which always makes a problem a little more confusing. But so I would advise you start way over here on the edge of the paper. So what are we starting with? What do we know at the beginning of this problem? We know that we have 4.7 anaes. So again, you don't even have to understand. Believe me, a lot of the chemistry problems, you will not understand just intuitively what that problem is trying to do. The only way you're going to be able to get the solution is by setting up the units properly. And then you'll say, okay, there we go. That got me to my answer. Okay, what do you want? Way over here on the right. And again, this still may not leave you enough space in the middle. But I'm going to write it here anyway because I'm not going to do this whole problem for you. I want you to knock this one down and we'll see what kind of answers you come up with. I always draw like a little blank line, meaning that's where my answer is going to go. And what I'm trying to find is hectares. How many hectares? Okay, so I even put a little question mark there. So we did this in a previous lesson, right? And an equal sign. So in between, you are going to have a whole bunch of boxes, right? Remember how I did that on one of the others? So I'm going to put one here, like this. And if I draw the boxes that big, I'm going to run out of space here. So you might want to write your hectares down there. I don't know. And remember what you can do out of each of these is you can create a ratio. So I can either write, let's just take this one as an example. I can write 2.8 Nemaya for every 4.4 anae, or 4.4 anae. And do you actually have to write these out every time like this? No. You get to where you just do them in your head. You know, you understand that relationship. It's one over the other, and then you flip it. And that's going to be 2.8 Nemaya. Okay, so which one of those are you going to use? Well, first of all, why did you use... we are going to use that one first, but why? How how do I know that's the one I want to use first? It's not because it just happened to be in the first box. There's a reason why. What's the reason that I wanted to use that one first? Look at all of them. Look at all of these. Okay, we need to make ani cancel out because ani does not appear in our final answer. So that means ani has to go away. There's only one that has ani in it. None of the others have ani in it. Now all the others except one with Hector have more than one, have the same person's name more than once. So you're going to have to think about it a little. And I call this building the bridge. I work in from both sides, and I'll show you what I mean in a sec. So that means we got to pick one of these two for this. Which one are we going to pick? You're going to pick the one that has ani on the bottom so it will cancel out. So I've got 2.8. And I've got 4.4 ani. So ani is going to cancel. There's no other that had ani in it, so that's the only one, that's the only possibility there. Now let's go over to the other side. I need to have one that's going to leave me with Hector's on the top. Hector's, Hector, doesn't matter whether it's plural or not. Okay, which one? Well, there's only one of them that has Hector in it, and that's this one. So where do I want Hector? I want Hector on the top or on the bottom? I need Hector on the top. So I'm going to come over here, and I'm going to write 3.4 Hector. Hector's going to be the last man standing, so that's going to be the unit in my final answer, and that's over 9.3 Odali. Okay, so I've taken care of two. By the way, you could scratch them out once you've used them. Okay. All right, now what? Think about it. I'll give you one more clue. How many do you have left? You have 1, 2, 3, 4, 5. You got Odali here. She doesn't appear in the final answer, so she has to cancel out. So which one are you going to choose, and which ratio, which Odali on top or Odali on bottom here, are you going to choose? Well, Odali, I only see one Odali. There it is right there. And so you're going to make a ratio, and in this case, Odali goes on top to cancel out with Odali on bottom there. So you see how you can build this. So that's as far as I'm going to go with this. And I'm going to leave you to do that one. Okay, so that concludes this lesson. Again, you can use these lessons as you need them. You can watch all the explanations, or you can just kind of click ahead to see the answers if you think you've done them right. But I want to be sure you know how to do them. That's always the important thing to get ready for AP. Okay, so we'll see you in class on Monday, and see you for the next lesson here.